Good morning, good evening, and good afternoon to all of you, those who have got this opportunity to learn this course of practical electronics. I feel it would be more helpful and supporting if I should make up your mind very much clear about some of the very basic terms used before stepping into the world of electronics. I shall make you first of all aware of the following terms used in electronics because this course is for all those who are beginners or students and maybe doesn't know a single word about electronics. So they require attention at very grassroots level to further proceed and jump up into this course for achieving maximum benefits of this course. Following are the basic terms used widely in electronics which require attention to clear up your basic concepts. We can also call them the basic pillars upon which the structure of electronics is being built and mounted. For example, what is electricity, what is voltage, what is current, what is power, what is closed and open circuit. Familiarization of measuring devices like digital multimeters, resistances and capacitances. With the passage of time, you will become familiar with all those concepts in more detail, but at the moment, it is compulsory for you to have some basic know-how of these concepts. Now, coming to the first chapter of your basic electronics theory portion, in which the first topic is electricity and the electron. What is electricity? Electricity is the flow of electric charge around a circuit carrying energy from the battery or power source to components such as lamps, motors, and other consumable electronic appliances. We may call it a load. We can also say load is an output device that consumes electric energy from an electric circuit. Electricity can flow only if there is a complete path from the battery or power source through wires to components. And back to the battery again. We cannot see the electricity physically, but we can feel, hear, and observe the effects of electricity flowing through a load. For example, heating of a heater when connected with power source, running and turning of an electric motor, generation of sound from an audio tintron, cooling effect of an AC, or glowing of an incandescent lamp. Flow of electricity is also called flow of electric charge that can be due to positive charge as shown over here. When the switch is closed, we can see over here that electric charge is flowing through the load. This electric charge can be due to flow of positive charge or due to flow of negative charge. Due to flow of negative charge is also called due to flow of electrons. So we can say that the electric current is flowing through the circuit. The flow of positive charge, due to this flow of positive charge, the current is called the conventional current, and if we consider the flow of electric charge due to negative charge or due to electrons, we call it the actual or the real current. Flow of positive charges from the positive terminal of the battery towards the negative terminal of the battery after passing through the load, and flow of negative charges from the negative terminal of the battery after passing through the load and then back to the positive terminal of the battery source. In both cases, whether you are using the conventional current or whether you are using the actual current flow, In both cases, the amount of charge flowing is of same rate and capacity. For simplicity, electric charge or electric current almost through all conductors and circuits is really the flow of negative charge, the flow of electrons, which is from negative terminal of the battery through the load and then towards the positive terminal of the battery source. A circuit, these are the basic circuits. A circuit is an arrangement according to the requirements to regulate the flow of electric charge in a controlled manner. The circuit is composed of wires, like shown over here. These are the wires. Electric components, like this. The load is, in this case, an incandescent lamp. This is an electric component. And the power source, which is electric power source. Here you have connected this DC power source. Here is also connected over there. The DC power source is your electric power supply. Circuits are of two types: closed circuits, like shown over here. This one is a closed circuit. This is also a closed circuit. And this one is an open circuit. A closed circuit like this one or this one is also called an active circuit. And an open circuit is called a passive circuit with no current flowing through it. Now we will discuss some basic circuit symbols to realize. Here you can see the circuit symbol of a bunch of wire. Wires can be used in these two configurations. These wires represent they are not joined by any means with each other. Where, however, if we can see over here, these wires are being connected with each other. Here you can see wires joined. The diagram of this is this one, and wires not joined. The diagram of this is this one. This is a cell, a DC battery source. A single cell is represented over there. This is a symbolic representation of a single battery cell. This one is the positive terminal and this one is the negative terminal of this battery cell. This is a DC battery source having many cells inside mounting in this battery source, which are internally connected with each other in serial or in parallel combinations. These are the physical appearances of the components used for power applications or DC power sources, whereas this one is the symbolic representation of a single cell, and this represents the symbolic representation of a complete battery unit in which many cells are being connected in series to build up voltage level accordingly. Later on we will use DC power supplies and AC power supplies. These are the representations of AC and DC in different notations. DC stands for direct current, which means the current flows only in one direction. Batteries and electronic devices like television, computers, and DVD players use DC electricity. Once an AC current enters a device, it is converted to DC. A typical battery cell supplies 1.5 volt of DC. Now we come across another component which is fuse. This is a symbolic representation of a fuse, and this is the physical appearance of fuse. The fuse breaks the circuit if a fault in an appliance causes too much current to flow. This protects the wiring and the appliances if something goes wrong. The fuse contains a piece of wire that melts easily if the current exceeds the current rating of the fuse wire. The wire heats up until it melts and breaks the circuit. It also acts as a barrier between the electric circuit and the human body. It is a kind of safety device for protection of human body and electrical circuits when short circuiting occurs. Now coming back to another important component of electrical electronics engineering, which is the transformer. Here you can see the symbolic representation of a transformer. This one is the physical appearance. A transformer is a device that transfers electrical energy from one side of an alternating current circuit to one or more other circuits, either increasing, which means stepping up, or decreasing, which means stepping down the voltage. It only works on alternating current and alternating current voltage sources of power. It doesn't work for any DC current or DC voltage sources. It works on the principle of magnetic induction and having no moving parts. It is a passive component that transfers electrical energy from one electrical circuit to another electrical circuit. We may call it a device used in AC power transmission of electrical energy. Here you can see the AC supply. This one is the AC outlet which is being provided at your homes, across which you can measure a voltage level of 220 volts AC with a frequency of 50 hertz or 60 hertz, whatever that is being provided you at your own country level. Alternating current is an electric current supply which periodically reverses direction and changes its magnitude continuously with time. Here you can see the wave form of an alternating current, which is periodically changing its direction accordingly with the passage of time. This is your timeline. This line represents the amplitude of an AC current, both in positive as well as in negative direction. It also provides the magnitude or the value of voltage level, either above the zero potential or below the zero potential. It has crust and trough along with variable polarity. In AC circuits, the flow of electrical charge, or in other words, electrons, periodically reverses their direction. The typical waveform of an AC is a pure sine wave. This is a sine function, which I'll discuss later on in detail. This represents a complete cycle. The time required to complete this one cycle is from here to here. which is called the time period of this one cycle of alternate current. Both this process of moving forward and backward is very fast. It completes many cycles in 1 second. The unit of measurement of an electric cycle is in hertz, and the number of cycles which the current completes in a second is called the frequency of an AC current, which is about 60 hertz in North America, and in Europe it is 50 hertz. One complete variation of an AC current is called a cycle. This one is another important symbolic representation. It represents the earth, the electric ground. In electric engineering, ground or earth is a reference point in electric circuit from which voltages are measured, a common return path for electric current, or a direct physical connection to the ground or to the earth. Electrical circuits may be connected to ground for several reasons. Exposed conductive parts of electrical equipment are connected to the ground to protect users from electrical shock hazards. Connections to ground also limits to build up a static electricity. For measurement purposes, the common ground or earth serves a 0 volt potential reference against which other potentials with polarities positive or negative could be measured. It is called 0 volt reference point or common ground for all return paths of an electrical circuit. This one represents the lamp, which is an incandescent lamp. This is the symbolic representation of incandescent lamp. This is your electric bell, and this one is the symbolic representation of electric bell. These are the lamp indicators, and the symbolic representation of lamp indicator is like this one. This is your buzzer. This is your physical appearance of buzzer, and this one is the symbolic representation of a buzzer. This is your heater, which is the physical appearance, which is shown. It represents a heater, and this one is the symbolic representation of a heater. This is your electric motor, or we call it an electric machine. This is the symbolic representation of your motor. This one represents a switch. This one is the symbolic representation of a switch. This switch is called push to make switch. It is a type of electrical switch where the connections inside the switch is wired to be normally open. When the switch is compressed, like this one, when compressed downward, the connection is made which allows the electricity to flow, and the switch is set to be on. In push to break, this one is another switch, which is the push to break switch. Its function is reversed. In normal conditions, this switch is supposed to be normally closed, but when pressed or compressed, the connections disappear or breaks up, and the flow of electricity is switched off or disconnected. This one is push to make switch, and this one is push to break switch. These are some other switches. This one is your dual on-off switch, which is DP-ST switch. This one is your reversing switch, which is DP-DT switch. This one is two-way switch, which is SPDT switch. SPST, single pole single throw switch, which is called on-off switch. These are two single pole single throw switches. Pole refers to the number of circuits controlled by the switch. Single pole switches control only one electrical circuit, whereas double pole switches control two independent circuits. ST stands for single throw switches. These are single throw switches. Those refers to the extreme position of the actuator. ST close a circuit only at one position. In both these cases, you can see. The other position of the handle is off. A single pole, single throw, like the one shown over here, single pole, single throw. SPST switch is a switch that only has a single input and can connect only to one output. It serves in electric circuit as an on-off switch. A resistor is a passive two-terminal, 1 and 2, two-terminal electrical component that implements electrical resistance as a circuit element. Resistors are used to reduce current flow, adjust signal levels, to divide voltages, for limiting electrical current and controlling voltage and current. Its unit is in ohms, whereas some multiples of ohms are kilo ohm, mega ohm, etc. We can measure its value either through digital multimeter or by reading its color bands. These are the color bands you can see over here. It is of two types, fixed and variable. This one is the fixed one. These are the two variables. Even this one is also a variable. Both are manufactured in different power ratings, either fixed one or the variable one. These are manufactured in different power ratings. Some value of resistance can be of different power ratings. For example, quarter watt, half watt, 1 watt, 10 watt, 100 watts, and maybe 1 kilowatt.